Hello, I'm Isaac. I want to explain what I refer to as Poisson Regression in Stata. I promised in the previous video that I'm going to continue with it. When do we use Poisson Regression? We use Poisson Regression whenever we have a count response variable. That is when the response variable is appear in counts, like how many per farmer. The data I used in previous video is what I will continue to use here. The farmer ID, the second column is adoption. You can see it as 1010 and so on. That was when I used binary logistic regression as response variable. But in Poisson regression, adoption cannot be our response variable. It's going to be pest incidence. Those are the farmer whose farm were infected by pest. And you can see here the first farmer with farmer ID of 1 was infected 3 times. This one is 1 time. Look at their ages, look at the farm sizes. So these are just 10 samples of farmer. Now we want to see how we can use, now making pest incidence as response variable, because it appears in counts, so we can count how many, and that is when we make use of Poisson regression. So I want to go to the analysis quickly. Now with this on ground, you can go through statistics. All we need to pick here is count outcome. You can see this is Poisson regression, and we pick this. I prefer using the command, but for those that are learning Stata, or maybe this is new to them, you can pick it from this place. And we pick under dependent variable, we pick pest incidence. Under independent variable, we pick age and farm size. Then we OK it. So the result comes out here. I want to go through usage of command. Just write Poisson, and I pick my response variable from this place, followed by age and farm size. Those are independent variables. Then I enter it. Now you can see the same result. Let me quickly explain the outcome. Now starting from what we have here, number of observations is 10. This is likelihood ratio chi-square, degree of freedom of 2, and the value here is 0.51. Well, what this one means can be explained by what the p-value is. See, this is how the p-value is written. Now this is 0.7738. This is far above the threshold, the cutoff or the level of significance of 0.05. This is far above it. Therefore, we are saying overall, we can summarily say here that the model does not significantly show that the independent variable contributes significantly to what the pest incidence is. Now in this case, let me explain this. Pest incidence in this case, we say it's count, but it's going to be log of the counts, because we are talking about Poisson regression. It is log count of the response variable. So here, look at what we have as 0.04467. This is very low also. How do we explain this? We say additional year in each of the farmer. Maybe a unit increase or a unit increase in their ages shows that it's going to be increased by 0.0446, which is very low. The contribution is very low. So a unit increase or additional unit increase in farm size also will reduce the effect on the pest incident also. It does not contribute. That's what it means. Now look at what we have here as p-value. P-value, all of them are far above the threshold. They are greater than 0.05. So we say we are not rejecting H0 for these two. Overall, yeah, the same thing with the constant, the estimate. So we are saying that this one is telling us that Even if the model does not have any predictor, it doesn't have any change. So this is not, the two of them do not contribute significantly. You don't have any significant relationship with pest incident. But whether the farmer is going to have incident of a pest or not, these two factors are not the one to talk about it. And the R square here, look at the goodness of it, only 0.01, you can say just like 1% of the variation the response variable is explained by the model, which is very low. So this is how we interpret, and this is why we apply Poisson regression when it comes to count response variable. Thank you. In the next video, I'm going to explain other family of nonlinear regression to data that happen or that occur in economics or agriculture generally. Thanks for watching.